relativity, the explanation for gravity is that matter bends space. And so you put mass in a place in space, it warps space-time, and objects are not feeling a force of gravity, they're just following the natural curvature. And so this is a sheet of Lycra. Where do you get this? This is my old bike shorts. No, there's literally a spandex.com. You can get a sheet like this if you buy the sale stuff, so you don't care what it looks like, right? For like 20 bucks, maybe less, depending on the sale. And so you put matter, and it warps space-time. And so if I have another object, it also warps space-time. They feel that, and they're attracted to each other. And so that's Einstein's picture of gravity. Objects warp space-time, feel that curvature, and move accordingly. And if you have more mass,
you're right there on that.
Oh. If you have more mass, it's going to bend space-time more. And so if you have objects here, they are going to respond to that, right? And so you put something there, now it's attracted. Now, in reality, that big mass would feel the warping of space-time by the marble too, right? It would move a little bit, but we usually ignore that. You know, the Earth makes the sun move a little bit, but it's so small you can ignore it. The moon makes the Earth kind of wobble around a point 3/4 of the way from the center of the Earth. We usually don't account for that when we're looking at satellite motion. Well, instead of just letting go of one, what if I give it a sideways push? Now it orbits. Now it's losing energy, which wouldn't happen in the solar system, right? Not noticeably. There's some perturbations from other planets and things, but this one does lose energy and spirals in. If I don't push it as hard, it will do an ellipse for a while anyway. And let's get some more here. So one of the things I thought of to do with this is when you study the solar system, all the planets are going around the sun the same way. Why is that? Did God decide that he only liked clockwise, or depends on whether he's above or below the solar system, right? Why is everything going in the same direction? Well, the answer is it wasn't. Different directions. But there was a preferred direction. The disk it formed from had a slight preference one way versus another, and things going the opposite way got eliminated, and when it's all said and done, everything's going the same way. That works 90% of the time.
Is it like the toilet flushing? Southern Hemisphere?
Wow, can you do that again?
And so, it won't work then. And so I have slightly more in one hand than another, but I don't consciously do that. And you want to get them so they spread out a little when you throw it.
It's because they're colliding with each other that you...
The ones going the wrong way get eliminated, right? Now there also would have been, this is where this analogy breaks down. There's, another dimension, right? But those things that were out of the plane also, that weren't near the preferred plane, also got eliminated. And so that's kind of cool. Now my students use a PHET simulation called My Solar System, and so they've seen all this on the computer, and when we do this during our special relativity unit, they're like, hey, it's just like the computer. That's kind of cool that a stretched sheet of Lycra models things, it's not just like it, but similar to the computer. Now, some things we've discovered using this, also had just some larger marbles, might as well put them out, but they bend space-time too, right? And so maybe, oops, you can get one thing to orbit another. Maybe I can do a little better. There we go.
Oh my God.
So the Earth-Moon system, maybe? And so you can see that this seam, you can't buy Lycra this big. You get it in rolls, and you have to sew it together. I've been told to use stretchy thread to sew it together. And so next time I do it, I'll do that because it pulls. And so just a little bit of thread fixes it. And so in the morning, when I first set this up, I'll have it leaning against the table. I'll be underneath fixing holes from last year. One time my principal walked in. And I hear somebody in the room, and I'm underneath, I'm in the middle of sewing it, I'm not going to pause yet. And then he's looking around for me, and he kind of knows somebody's in the room. And he says, oh, there you are. He goes, what are you doing there? And I go, I'm repairing a rip in the fabric of space-time. What do you think I'm doing? How often do you get to say that? Another thing this does, you've probably seen plastic ones of these, right? The Discovery Center, Children's Discovery Museum in San Jose has one, the Exploratorium has one. Sometimes they have them at shopping malls to get you to put money in it. But one thing you can't do with those is put two masses in. And so when we went to the moon, when we first started, we sent our spaceships on what are called free return trajectories. So they would go to the moon, this is hard to get to happen, and they would come back in like a figure eight. And so that lets you show, now of course the moon's a lot smaller, but if you look at the plots of the free return trajectory back from the Apollo program, you'll see it has a figure eight sort of shape. And so this takes a little bit of practice to be able to do the figure eight. These clamps around here, you can adjust it to make it tighter if it's not working. So Steve and I, when we set this up in the morning, we played around with it, and actually I think it was working better than it usually is. All of this, so not easy to do. And so I go through that. One year a kid who read some stuff about the dark energy. We have our dark energy pole.
It's over there.
I happen to have an extra pole. I guess any of these would work. And so I'm just thinking, oh, dark energy, what is that? That makes everything come apart, right? And so dark energy would be that. And so stuff goes apart rather than toward it. So if you can work in dark energy anytime, right? And so I go through that spiel. Maybe it takes me 10, 15 minutes talking with the kids, you know, just stuff they're not familiar with. And then I just let them play. And so that's where we discovered the Earth-Moon thing. Is I just let them play, and they're like, Mr. Burns, come over here and look. And they were all excited because they discovered that. I said, oh yeah, it's got it.
Wow, so wow.
And so there's, you know, then I throw out a few other things so they can try this collected stuff over time. And put out all the marbles. So if you want to try it out, but we probably want to get back to electricity, magnetism.
But we want to play, Mr. Burns.
And so I'd say the whole thing, if you bought all the parts and everything, it's about $100. But one of my favorite days, so you're going to do it Monday, right, Steve? You didn't get to it. But just, you do it once and you'll be hooked. And it will take a little bit of fooling to put it together, but I'll post the plans, and it's not a whole lot of work for.
So this is a take-apartable thing, right?
It comes apart, all the PVC pipe, wrap it with a bungee cord, stuff the Lycra in that box, and I can carry the whole thing myself. This is about the right size. You can get your whole class around it pretty much. Smaller. One problem is reaching. So some of you, I think, would have trouble with that, so you get a student to do it right. One thing you got to watch, though, is some students will think to go underneath to push up, and then while they're underneath, somebody decides to put the big mass down, and you know they get their space-time warped. And so you just tell them you can't go under. We will get things ourselves. We don't need to do that.
Even Einstein has rules.
Yeah. And so, is general relativity in the state standards? No. Probably the crowning achievement of science, not in the state standards. Can you fit it in after the STAR test? You bet. You can find some videos. I show them a thing on gravity waves, and then we do this, and that's, a day, almost a day on general relativity. But since I don't understand it myself, that's plenty. So let's go back into the room.